All right, so when we last left off in Precalculus for lesson 2-3, we had started on example 2. I didn't really give enough people or enough time for people to get to this point, so make sure you got at least these numbers. Let me re-explain where example 2 is coming from. Again, Jaden's rule states that I take my first term, 3x, and that is the first term that's going to be to this power, to the power 5, and then it's going to be that same 3x to the power 4, same 3x to the power 3, and then the powers descend to 1, and then until it's gone. So notice that there's no term right there. And then the second half of Jaden's rule states that negative y is going to be at the very end to the power of 5, so negative y to the power 4, then 3, then 2, then 1, then nothing. So we have Jaden's rule out here. The blue numbers was from Pascal's triangle in our fifth row because the second number is a 5, so it goes 1, 5, 10, 10, 5, 1. And you can see in blue over here, I have 1, 5, 10, 10, 5, 1. What I'm working on now is I'm trying to simplify everything right now. So I need to figure out what is 3x to the power 5. And just as a reminder, if I have 3x to the power 5, the quantity of 3x to the power 5, that is not just 3x to the 5th, that is equal to 3 to the power 5 times x to the power 5. So we need to figure out what 3 to the power 5 is, and it's kind of a big number because what is 3 to the power 4 is 81, so times 3 again is that 273? I think so. Let's see. 3 to the power of 5, 243. Dang it. Okay. 243. So this is going to be 243. And then I have this x to the power 5 times that blue coefficient 1. And all of that is just going to be x to the power 5. Sorry, my throat is bothering me because I ate way too spicy food for lunch. From here, we're going to do 3x to the power 4. So 3x to the power 4, 3 to the power 4 by itself is 81. So 81, then I have to multiply that by 5, just in terms of the coefficient up front. So 81 times 5 is 405. So this is going to be minus 105. Why? Again, 3 to the power 4 was the original. Wait a sec. What did I just say? 3 to the power 4 is 81 times 5. Okay, 405. Why did I write 105? 405, sorry about that. Why negative though? Because I have a positive 5 times a positive 81, because I was to the power 4, times a negative. That's where the negative came from. So I have minus 405, and then I'm going to have x to the power 4, y. X to the power 4 and y. Next, I'm going to have 3 to the power of 3. That's going to be 27. So this is 27 right here. You can maybe label this in the notes. 27 times this positive 10 is positive 270. Ooh, we have to worry about the negative though, right? I'll leave 27 there. The negative right here is being squared. A negative times a negative is a positive. And just as a general note off to the side, if I have a negative to an odd power, that's going to be a negative. If I have a negative to an even power, that's going to be a positive. And then if it's a positive to an odd or an even, so positive to an odd power and a positive to an even power, those are always going to be positive. If you start with positive, you can't get negative. Oop, I wrote double plus, so is equal to a positive. I can put parentheses around that to make it more consistent. So this is a negative to an even power. A negative to an even power is always positive. So I don't have to worry about this negative symbol right here. So I just have the 270 from the 27 times 10. So plus 270. How many variables do I have? I have 3 x's and 2 y's. So I say x to the power of 3, y to the power of 2. All right, next. Notice that in terms of being positive or negative, I have a negative to a power of 3, a negative to an odd power. So I know that I'm going to be having a negative. And then time to figure out what that coefficient is. So it's a negative something. It's 3 to the power of 2, which is 9. And 9 times 10 is 90. So our coefficient is 90. How many x's do we have? We have x to the power of 2. How many y's? Y to the power of 3. And we're good. Okay, next term. Notice I have a negative to an even power, so it's going to be a plus. And coefficients, 5 times 3 is 15. How many x's? Just 1. How many y's? Y to the power of 4. And finally, I have 1 times this negative y to the power of 5. Again, a negative to an odd power is a negative, so it's going to be minus. And I don't have any x's, I just have y to the power of 5. We've got weird lag there that happened. So it's very similar to the last problem in terms of just simplifying your coefficients. The one difference is that we had a negative in this problem, right? And a good shortcut to make sure that you are making doing the right problem is it should always start off, or it should always alternate between positives and negatives. So I'll have positive 243, then a negative, then a positive, then a negative, then a positive, then a negative. It should always go back and forth. If you randomly get positive, negative, negative, you've done something wrong. It should alternate. That was example number 2. Let me do example number 3, and then the hard example number 4. So in example number 3, it's just the power of 3, but they're slightly bigger numbers in here instead of like 2 or 3. They're 5 and 4, so a little bit scary. So again, Pascal's triangle is my first step. So I go to row 3 of my Pascal's triangle. Maybe it would be worthwhile copying this down, but I know row 3 is 1, 3, 3, 1. So I'll come back down here and say my coefficients are 1, 3, 3, 1. And then I'm going to start using Jayden's rule. So I'm going to go ahead and say this 5r is going to be 5r, and that entire 5r is going to start with this power up here. It's going to be 3. And then it's going to be that same 5r to the power of 2, the same 5r to the power of 1, which is just 5r. Putting the 1 is a little bit reductive, it's pedantic, you don't have to really do it. And then this is 5r to the power of 0, or it's just 1, it's not there, so I'm going to not write it. Next, let's do the negative 4t. So on the far right, I'm going to do it in a different color. Let's do it in green. So this negative, and it does include this entire negative 4t. So I'm going to have the negative 4t, that entire thing to the power of whatever power I started with, 3. And then I'm going to have a negative 4t to the power of 2, a negative 4t to the power of 1, which is just negative 4t, and then no negative 4t. Again, the default should always be a plus symbol until you're proven otherwise. And then we just need to simplify. So 5 to the power of 3 is 125. So 125 times 1 is 125. 125. And then how many r's do I have? I have 3 of them, r to the power of 3. And there's my first term. Next, we got a lot of coefficients now. So 5 to the power of 2, I'm going to worry about him first, or her, I don't know. 5 to the power of 2 is 25. 25 times 4 is 100, and this is really negative 100, right? It's a negative 4. So I have negative 100 now, and negative 100 times 3 is negative 300. So minus 300. That's my coefficient. Once I get my coefficient, let's count the variables. I have 2 r's, so r to the power of 2. I have one of those t's, so there's my t. And I try to have my t's have like a little curl underneath here, so comes up like that. So I don't confuse it for a plus symbol. Plus. Again, first I want to worry about the exponents. I have this negative 4 to the power of 2. A negative to an even power is a positive, so I don't have to worry about the sign here. It should be positive. And it is a positive, right? Because it goes positive, negative. It should be a positive to continue the pattern. So it's going to be positive. 4 squared is 16. 16 times 5, I think that's 80. And then 80 times 3 is 240. So it's going to be 240, and then how many r's do I have? R to the power of 1, which is r, and t with a little curl under there, right, to the power of 2. And I'm not 100% confident about my math, so whenever you're like that, please just use a calculator to check your work. So I'm going to check. 4 to the power of 2 is 16 times 5, which is 80, times 3, 240. Whew. All right, we got the correct coefficient on here, 240. Now finally, I'm going to have a negative to an odd power, so this is going to be a negative. And it's going to be 1 times whatever, so it's just this thing. 4 to the power of 3, what is that? What is 4 cubed? 4 cubed is 64, but you can verify that on the calculator. 4 to the power of 3 is 64. So I'm going to say, oops, minus 64. And how many variables? I just have that t to the power of 3. And we're done. We can box it. I don't know if I boxed all my other answers. I probably just want to use a rectangle tool. So grab the rectangle tool. Let's make it outline in red, fill with nothing. So there's my final answer. You can maybe move that up. Go ahead and box my final answer up here. Shwink. All right. And I want to make my rectangle look really nice and neat. So I'm going to go ahead and use the rectangle tool for this one as well. Yoink. All right, and finally, example number 4. I have a lot of room, so I'll be careful. This one is ridiculously hard. Well, it's kind of cool though, because things will cancel out. So there's a few different ways to do this, and I'm not sure which one is better. Maybe I'll just show you both. So the property that you need to know for this is whenever I have 1 over c and I take that to some power, I'm just going to randomly choose, I don't know, 3. That is equal to 1 cubed over c cubed, which is therefore equal to 1 over c cubed. So it's, I mean, if you're doing a shortcut from the first step to the last step here, it's essentially just applying the 3 to the denominator. Why am I showing you that? Because we have a 1 over c that's going to be raised to certain powers over here. Notice that I don't want you to have to worry about signs in this one. Strictly focus on how c and 1 over c are going to cancel each other out as you move through the problem. So it is to the power of 6. Again, your first step should always be use Pascal's triangle to help you set up your coefficients. So row 6 is 1, 6, 15, 20, and then it goes backwards. 1, 6, 15. I'm going to run out of room, aren't I? I'm going to do 2 lines of an equation. 1, 6, 15, 20, and then it goes backwards. So 15, 6, and then 1. So there's 1, 2, 3, 4, 5, 6, 7 terms, which makes sense, right? Because when it's to the power of 2, it was 3 terms. It's always 1 more than this number of terms. Okay, we have our coefficients set up. It's time to use Jayden's rule. Jayden's rule states I'm going to take this variable and then I'm going to raise it to this power from the very beginning. So it's going to be c to the power of 6, and then it's going to go down. So it's going to go c to the power of 5, c to the power of 4, c to the power of 3, c to the power of 2, c to the power of 1, which is a c, and then no c at all. Next, I'm going to look at, and I should use my colors here so you can color coordinate. Notice that at the second term, I always circle the sign in front just in case it is a negative. In this case, it's a positive, so I don't have to. And I'm going to start on the very right-hand side. So this is going to be 1 over c, and that's all going to be to the power of whatever this original power was, 6. And then this is going to be 1 over c to the power of 5, 1 over c to the power of 4, 1 over c to the power of 3, 1 over c to the power of 2, 1 over c to the power of 1, which is just 1 over c, and then there is no term here. I probably spaced these out too much, but that's okay. So the default sign in between each of these is a plus symbol until you're proven otherwise. There's no negatives that we have to worry about, so it is going to stay a plus symbol. Now it is time to start simplifying. So when I'm looking at this first term, I can't do anything. It's just c to the power of 6. I can get rid of the 1, I guess. So this is going to be equal to c to the power of 6. Next, I have c to the power of 5 times 1 over c. And just as a side work, if I have c to the power of 5 times 1 over c, what's really happening here is you need to think of this as c to the power of 5 over 1. So you have a fraction times a fraction. You multiply the numerators, the tops, and you get c to the power of 5. You multiply the denominators, you get c, which is really c to the power of 1. I'm going to unsimplify it for a sec so it is helpful to see how this is going to reduce. The rules of exponents here state that whenever I have the same base, which I do, it's both the power of c, or both, sorry, a base of c, you just subtract the powers when it's division. So this is going to be equal to c to the power of 5 minus 1, which is just c to the power of 4. So I'm sure that you can probably start doing this in your heads. You can say, okay, that's 5 on the top, 1 on the bottom, 5 minus 1 is 4, and then just immediately come down here and say, oh, that's going to be plus 6. I can write it over here a little bit, 6c to the power of 4. You can immediately skip that step. So let's try it again, right? On this next one, I'm going to have plus 15. The coefficient is still 15. Notice that because both the coefficients are 1 and 1, I don't have to worry about changing the number that came from Pascal's triangle, this leading coefficient, which is kind of nice. So on the c to what power, though? It's going to be the power of 4 on the top, the power of 2 in the bottom. 4 minus 2 is 2. So I'm going to have c to the power of 2, which is kind of weird, right? But there is a pattern. It goes 6, then 4, then 2. You can probably take a guess what the next power is going to be. If you said 0, you are correct. I'll show you why. So this next one, I have plus 20 c to the power of 3 divided by, or I guess times 1 over c to the power of 3. So again, it's going to be plus 20. And when I have c to the power of 3, I'll just do some scratch work to make sure you guys trust me. C to the power of 3 divided by c to the power of 3. That means it's c to the power of 3 minus 3, which is c to the power of 0. And anything to the power of 0, c, x, 1, negative 100, anything to the power of 0 is 1, which means I really have 20 times 1, which I'm not going to write. I'm just going to write 20. That's the simplified version of it. Next, we have this 15 term, so plus 15, and then you can probably take a guess what's going to happen. I have c to the power of 2 on the top, c to the power of 4 on the bottom. So there's two different ways that you can write this. I'm not sure. I think both of these will probably be correct on Khan Academy. But mathematically, you can do either one of these for the quiz and the test. If I have 15, let's just do a more simple example. If I have something like c to the power of 2 divided by c to the power of 4, what do you write here? Well, you can either write c to the power of 2 minus 4, which is equal to c to the power of negative 2. That is correct. Or you can subtract the other direction. 4 minus 2 is 2, and you can say that is equal to 1 over c to the power of 2. Because I know the bottom is bigger, so that's where the power is going to stay, and 1 is going to be on the top now instead of the bottom. I personally really like fractions. Negative powers are a little bit confusing me, but you can do whatever floats your boat or sinks your sub. So I'm going to write over here 1 over c to the power, or 1 over c squared. Yeah, sure. Just leave c squared in the bottom in the denominator. Next, I have this problem right here. So it's going to be plus 6. And then notice I have 1c on the top, 5 c's on the bottom, which really means 5 minus the 1 on the top is 4 c's in the denominator. So it's going to be, not plus, it's still 1 over c to the power of 4. And then finally, just 1 over c to the power of 6. So plus 1 over c to the power of 6. And these really can be simplified, just those two. Why? You can really rewrite this as 15 over c squared, and you can really write this one as 6 over c to the power of 4. I'm pretty sure they'll still give you credit like this on Khan Academy, and this answer that I've written right here is 100% acceptable on quizzes and tests for my class. But I will give just a note, they can be simplified to something that looks like that. So I said that this one was hard, but it looks kind of easy. There's less multiplication. There's no 3 to the power of 5 or anything like that. The coefficients are easy. It's just you're using more rules of exponents, properties of exponents that you might not have been expecting. All right, that concludes Precalculus Notes 2-3. I'm recording this obviously by myself since you don't hear anyone else participating. Hopefully your 5 for the objective is a little bit higher. I know that it is a harder lesson, so good luck on the homework. I'll see you guys later.